Hey everyone, welcome back to the channel. In the previous video, we've seen what are the benefits of having a cloud infrastructure. We've seen how it helps us in terms of the cost optimizations and what are the different kinds of models, service models that cloud offers, whether it's infrastructure as a service, software as a service, or platform as a service. And then we've also seen the different responsibilities or the responsibilities changing across these different service models. Also, we have seen the different kinds of cloud models that we have, whether it's a public cloud, something like an AWS, Azure, or a GCP, or a private cloud like a VMware or Oracle, and then there's a hybrid where it's a mix of both public and private cloud, depending upon the use cases that one have. In this video, we'll understand few of the essential cloud concepts which are very much needed in order to make your cloud journey smooth. The first one for today is scalability. So by definition, what scalability means is in order being able to increase or decrease the resources on demand, whether the system is able to do it or not. Often the term scalability is confused with the term elasticity or being elastic in nature. So which means that if a system is elastic, which means the system is able to scale up and down as and when needed. Now let's understand with the same scalability using the pizza analogy. Let's say. So let's say, for example, there's a pizza shop, and then you have one chef making all your pizzas or all the pizzas that are being ordered by the customers, and then all of a sudden your pizza seems to be having a good taste and the recipe seems to be liked by the customers. There's a huge uh, request coming in, and then there are huge customers waiting in the line to have the pizzas. Now what happens is, since there's only one chef doing the job, it may get delayed, or you may ask the chef to do overtime in order to handle this request, which means that you are trying to have a single chef doing most of the job beyond his limits, which is in line to what vertical scaling means, where instead of having multiple such chefs, you're trying to use the same chef maybe to increasing his limits. Similarly, in case of systems, what happens is what vertical scaling means is, let's say you have a memory of 128 gigs handling the resources or handling the requests coming in. Now, when there's a huge load on the systems, you have observed this. What you tend to do is, or what vertical scaling means is, instead of having 128 gigs, you would increase that to 512 gigs. It could be temporary, but still. This means that you're trying to upgrade the hardware as much as possible to its limit. So, and then there's another way of doing it, which is horizontal scaling, which means that when there's huge load, when you anticipate that there would be a huge load, what you would do is you hire another chef for maybe a particular day, or there's some sale going on, you hire another chef for a particular day so that the number of requests gets distributed among those two chefs, which also helps or benefits in distributing the load, delivering the orders quickly, and also serving the customers as quickly as possible. Which, in terms of the systems, what this means is horizontal scaling, which means you're scaling outwards. So, as and when needed, you're increasing the number of systems, which means that let's say there are 100 requests coming into a single system. Now, your 100 requests are distributed among two systems, which means each of the system gets 50 and no system is burnt out. Now, let's also understand what are the pros and cons of these vertical scaling and horizontal scaling. Now, the problem with vertical scaling is that since you're having a single chef, let's say you have not, you're trying to, put a burden on the chef a lot. Now, what happens with this is, for instance, let's say the chef isn't healthy up on a particular day, which means that you will not be able to serve any pizza orders for that particular day at all, which is called as single point of failure. And also, there would be a certain limit to extend your hardware or to make a human work. So you just have a limitation on this point, on this on expanding your or upgrading your service to a certain limit. And it also incurs more cost when you're trying to do so. If you have to ask a chef to do a lot of overtime, you may have to pay the chef a lot more as well, because you're trying to get squeeze the most out of the person. Similarly, in case of the systems, when you're trying to increase the hardware to a certain extent, you may be paying a lot. In case of horizontal scaling, what happens is there would not be this concept of single point of failure, because you're having multiple systems, and even if one of the system fails, there will be other systems handling the request, and then the users are happy because though one of the chef is not available, the other chef is available. Maybe the load on the chef is a bit more, or maybe you may go ahead and call in another chef for that particular day. So the load can always be distributed, and you can also ensure that there is no single point of failure. And another thing is, you may not as well pay the huge amounts that you would generally pay if you want a single chef to be doing an overtime, rather than paying two different multiple chefs, because you're probably using the another chef temporarily. Now, another one is availability and reliability. Let's try and understand the same with the pizza analogy again. Being available is nothing but it's a percentage of the time that the system is operational or accessible, whenever needed. Like in case of pizza shop, the chef being available to prepare a pizza whenever there's an order request coming in. So which means that whether or not chef will be able to do it or not is secondary, but the chef being available to handle the request is called availability. So how is this achieved? So you generally be able to achieve this when you do not have this single point of failure concept. So you can achieve this using by having redundant systems, which is nothing but having the system scaled horizontally and distributing the load using the load balancer, so that when one of the chef is not available, or when one of the system is not available, the request still be served by another server or another machine. And the next thing is reliability. So what's important is not just being available, being able to do the intended function is also much more significant than being available. If the chef is available but doesn't know how to make a pizza, there's no point of having a chef. Similarly, the system being available but not being reliable has got no significance. So in order to make systems reliable, or in order to if the systems have to be reliable, you should be able to handle the you should be able to handle the errors quite robustly, and then you need to perform regular testing and monitoring, so that you would not face the reliability issues, and the system always delivers. Like for example, maybe you send an email via Gmail or some email provider. It is always expected that the email gets delivered to the destination without any fail every time. So that's being reliable. It's very rare that you see the Gmail system failing to deliver an email. So it's almost reliable. So that's reliability. So it's always necessary in the cloud systems, to provide the better user experience, the best user experience. Your systems should always be reliable. And the next comes fault tolerance. Again, sometimes the word fault tolerance is often confused with reliability. So the key difference is, or availability. The key difference here is uh, fault tolerance is nothing but it's more about delivering right data rather than just delivering data. So it's more like, for example, you take a banking system, or let's again go back to the pizza analogy before going to the banking system. Let's say one of there are you're having your pizza shop is having two chefs, and one of the chef is not unavailable on a particular day. Having another chef is being available. Having another chef knowing how to make a recipe is being reliable. Now, what fault tolerance is, the chef who is available being able to deliver the right one. Like, for example, if somebody orders a margarita pizza, the chef should be able to do a margarita pizza, not a pepperoni pizza. That's being delivering right. In case of systems, in case of computer systems, let's say if we consider a banking system and there's some failure in one of the region, this in one or when one of the data center, and the request when the user requests to check his or her balance, just because one of the database center has got some issue, the user should not get a stale data or an incorrect data just because one of your system is not ready to handle the issue. So it should always happen that if you are handling the request, you should always ensure that this request is handled, without any fault. And how can this be achieved? By having, probably replicas across multiple regions and having automatic failure mechanisms. So when something goes down, another DB gets started automatically, and then the replicas will be able to handle the request coming in. And also, in order to handle this much more gracefully, what you can also do is, let's say if there is some you know failure, the system which actually delivers you the balance is down. It's better not to serve the data rather than serving an incorrect data. So you can probably gracefully let the customer know that the system is down for time being, and maybe ask the user to come back a little later. That's more a better user experience than showing him or her an incorrect balance. So that's all for today. I think to recap, let's just go a little quick. Scalability is nothing but being able to handle the requests at scale. Whether you do a vertical scaling or a horizontal scaling depends upon your use cases. But ideally, in general, horizontal scaling is much preferred. That's how all the different things work in terms of, even in the world of Kubernetes containers. Horizontal scaling is the primary scaling that is employed, and then being available and reliable gives the users the best experience, and the systems being available and reliable makes your application look much uh, great in terms of user experiences, and the systems being available and reliable is quite essential and significant, and it all depends on how the systems are coded, how the systems are handled, how the maintenances are performed, and how the monitoring and observability metrics are employed. And then comes the fault tolerance, which is nothing but being able to deliver the right or accurate data whenever a request is handled, not just being able to deliver just the data. That's all for today. Thanks a lot.